Alright guys, well this is lesson 2. Our first lesson was on Monday, and even though online learning hadn't officially started, I kind of used it as a sample lesson. There was also an assignment with that, so if you haven't done that assignment or watched that lesson, go ahead and pause this video, jump back to those. You can find it in the lectures channel of Teams under, I believe that was March 30th, and then you can also do the assignment. When you guys do the assignment, make sure to do it in your OneNote, in your assignments tab, but also press turn in on Teams just so that I know that you've done it. So if you haven't done that one yet, go ahead and pause this video and jump through that. So today's assignment is the second half of this worksheet, and so to get us moving, if you've already done the whole worksheet, then you're already good. If you haven't done the whole worksheet yet, then the second half of the assignment is going to be, or the second assignment is going to be the second half of this worksheet. So what I'm going to do is I'm actually going to solve through these to help you guys. So if you struggled on any of them, you can see how they were done. If you didn't have any problems with this, then you can, and you've already turned in the first assignment, then you can just press turn in on the second assignment if you've done the whole thing already. If not, finish these and press turn in on Teams so I can see that you did it. So I'm just going to work through these things real quick. So in this first one, we're going to be, I see that we're using, we have how many moles of gas, and I have one volume, one pressure, and one temperature. So because there's no change in condition, I know this is PV equals nRT. If you solve this with kilopascals rather than with atmospheres, if you look down at the solution, you can see that they used 0.0821, which means that they're solving everything, or this worksheet's solving everything in atmospheres. If you used kilopascals, you're still going to get the same answer. You're just going to use a different R. But because the pressure is in atmospheres, we might as well use the R for atmospheres. So my pressure is 2.8. My volume here is 98. And that equals the number of moles, which is what I'm looking for, times 0.0821 times my temperature, which is 292 Kelvin. Now they already put my temperature in Kelvin, so I don't have to convert that. So I'm just going to take 2.8 times 98, and then I'm going to divide it by the product of 0.0821 times 292, and I'm going to get that N equals 11.4 moles. All right, number 2 looks trickier than it is. It's just telling me I have a mixture of two gases that together make 8.0 moles. Okay, so that's my N. I have one volume, one temperature, and it wants to know what will the pressure be. So again, this is PV equals nRT because I only have one of everything. Even though there's 2 moles here, we're adding them together so they act as a single unit. So it's just one thing of moles. So it wants to know what my pressure is when my volume is 30 equals 8, that's my number of moles, times R let's see, 0.0821. Because I used 0.0821, my pressure will be given in atmospheres, times my temperature, which is 25 plus 273. Remember that if you have degrees Celsius, you have to add 273 to equal Kelvin, and all our calculations have to be in Kelvin. So I'm just calculating this real quick. So I get that that's 195.7 on my right hand side divided by 30, and so the pressure is equal to 6.5 atmospheres. All right, number 3, a balloon is filled with, I have 35 liters of helium, and it's a temperature of 20 degrees Celsius, and I have a new temperature. So because there's a new temperature, I know this is P1V1 over T1 equals P2V2 over T2, but no pressure is ever mentioned, so the pressure must remain pretty constant. So I'm going to say that pressure is gone. So now I just have V1 over T1 equals V2 over T2, which is Charles' law. And so I'm going to say 35 over 20 plus 273 equals my new volume divided by 45 plus 273. So 35 divided by 293. And then I'm going to multiply it by 45 plus 273. And I get that the volume is equal to 37.98, so it's basically going to be 38.0 liters. All right, number 4. Number 4 says a 35-liter tank is at 315 Kelvin with an internal pressure of 190 atmospheres. How many moles? So it's just one of everything, so that's PV equals nRT. So the pressure is 190 times my volume, which is 35, equals N times 0.0821 times my temperature, 315. And then we just solved through. That one was real easy. Okay, so that guy comes out at the number of moles is 257 moles. Okay. Let's see here, number 5. A balloon can hold 85 liters of air, and it's inflated with 3.5 moles at 1 atmosphere. What's the temperature in Celsius? So this one we have to be careful because when we calculate PV equals nRT, the T we get is going to be in Kelvin. So I have the pressure is 1 atmosphere times 85 equals, let me see, how many moles? 3.5 moles times 0.821 T. So I have T is equal to 295.8. Then I have to subtract minus 273. Because remember, Kelvin minus 273 equals degrees Celsius, which is what it wants. It wants it in degrees Celsius. So I'm just going to subtract 273. And I get that the answer here is equal to 22.8 degrees Celsius. All right, calcium carbonate decomposes at 1200 degrees Celsius. If 25 liters of CO2 is collected at 1200 degrees Celsius, what will the volume be after it cools to 25 degrees Celsius? Well, this is P1V1 over T1 equals P2V2 over T2, except there's no pressure in this again. So I just have Charles' law again. So 25 liters over 1200. Remember, I have to add 273 because it's got to be in Kelvin, and these are Celsius temperatures. So what will the volume be when the temperature is 25 degrees Celsius? So here we go. 25 divided by 1200 plus 273 times 25 plus 273. The volume is equal to 5.1 liters. Okay. 2 more. A helium balloon with an internal pressure of 1 atmosphere and a volume of 4.5 liters at 20 degrees Celsius is released. What will the volume be when the pressure is 0.6 and the temperature is negative 20? So now we're going to use all P1, V1, and T1. So I'm just going to plug all my stuff in. I have 1 atmosphere for P1. V1 is 4.50 at 20 degrees Celsius plus 273 equals 0.600 V2 divided by negative 20 plus 273. So I'm going to figure out my left-hand side first. And I find that that's 0.015358 equals 0.6 V2 divided by 253. Multiply both sides by 253. And I get 3.886 equals 0.6 V2. Divide both sides by 0.6. And I get that V2 is equal to 6.5 liters. All right, and my last one here. My last one, number 8. I have 135 liters at that temperature, and I have 75 liters. What will the new temperature be? So 135 at 260 plus 273 equals 75 liters at T2. So 135 divided by 260 plus 273 gives me 0.253 equals 75 over T2. I'm going to multiply T2 at both sides by T2 just to get it out of the denominator. And then I'm going to divide both sides by 0.253. So I have that T2 is equal to 296 Kelvin. I have to subtract 273, which is going to be 23.1 degrees Celsius. So my answers are going to vary from the answer key at the bottom, only by sig figs. I didn't round them to sig figs. You can certainly do so, but if you see any discrepancy, that's why. So at this point, that's how you solve the first 8. You should be able to do the next 7 of them easily. So I hope you guys have a good time. Get these done, put them in your assignments tab, and then press turn in on Teams. I will have office hours again on Friday. Make sure you check the calendar. The times may vary now and then, and I may start combining the classes with office hours instead of doing different office hours for each class. So just check the calendar for the office hours. I update that almost every day when stuff's due. And so I hope everything's going well. If you guys need anything in between, feel free to email me. Have a great day.